we living in the only universe, or just one of countless parallel universes? Imagine, perhaps out there, myriad versions of yourself are living different lives in different realities. Modern science is unraveling this mystery, taking us from metaphysical concepts to dramatic physical theories. Are you ready to join me in exploring the infinite potential of the multiverse and brane theory? Welcome to SpaceTime's universe journey of discovery, where we explore the deepest mysteries of the universe. In this video, we will explore the multiverse and brane theory. Are there other universes beyond our own? Don't forget to subscribe to the channel so you don't miss out on other exciting universe exploration videos. If you find the video interesting and useful, please like and share to support us.
The idea of the multiverse is not a new concept in science fiction. It has become a serious field of study, driven by discoveries in theoretical physics and cosmology. Scientists like Stephen Hawking and Carl Sagan have touched upon the notions of the universe's infinite vastness, paving the way for deeper questions about our place within it. One of the strongest foundations for the idea of the multiverse comes from the theory of cosmic inflation. This theory suggests that immediately after the Big Bang, our universe underwent a period of extremely rapid expansion, far exceeding the speed of light. This process not only explains the uniformity and flatness of the universe we observe, but also hints at the possibility that other regions of space also underwent inflation, creating countless separate bubble universes. If inflation is an eternal, continuously occurring process, then our universe is just one of billions of such bubble universes. Each of these bubbles could have different physical conditions, fundamental constants, and even different physical laws. They are beyond our observation, but their existence is a logical consequence of the theory of cosmic inflation.
Another approach comes from quantum physics and the many worlds interpretation, MWI. According to MWI, every time a quantum event occurs and requires a choice, the universe splits into multiple branches. Each branch corresponds to a possible outcome. This implies that every decision you make, every path you don't choose, is happening in some parallel universe. For example, when a photon passes through two slits, it appears to pass through both simultaneously until observed. MWI proposes that instead of choosing one path, the universe splits into two parallel universes, one where the photon passes through the first slit and one where it passes through the second. This creates an infinite picture of universes, each representing a possible outcome of every quantum event. String theory and M-brane theory offer a completely different multiverse scenario. These theories propose that our universe is not the three-dimensional space we perceive, but a brane floating in a larger multi-dimensional space called bulk space. These extra dimensions are either curled up very tightly or spread out in ways we cannot directly perceive.
In brane theory, there could be countless different cosmic branes existing in the bulk space. These branes could be parallel to each other or even collide. If this happens, each collision could be a new Big Bang, creating a new universe with its own characteristics. This is the core idea of the cyclic universe model, where the Big Bang is not an absolute beginning, but a recurring event. The concept of extraspatial dimensions has been discussed in Stephen Hawking's works, particularly in his book, The Universe in a Nutshell. He discussed more complex universe models where space and time could have many forms and structures beyond our intuitive understanding. Brane theory is an attempt to unify the fundamental forces of nature, including gravity, into a single framework. In this model, we can only experience particles and forces interacting on our own brane. The only exception might be gravity, which is believed to be able to leak into other extra dimensions. This could explain why gravity is much weaker than other fundamental forces like electromagnetism or the strong and weak nuclear forces.
Types of multiverses can be classified in various ways, most notably by Max Tegmark. Level 1 is the extended universe, regions of space beyond our observable horizon in an infinite inflationary universe. These universes have the same physical laws and fundamental constants, differing only in initial conditions and matter distribution. Level 2 is bubble universes, universes created from different inflationary processes, with potentially entirely different physical constants and fundamental laws. This is where the theory of eternal inflation comes into play, where each bubble is an independent universe, completely separate from our own. Level 3 is the quantum many worlds, parallel universes arising from every quantum event, where all possibilities are realized. As mentioned, this is an interpretation of quantum mechanics, where there is no single choice, but all paths are explored in different universes. Level 4 is the mathematical multiverse, universes described by different mathematical structures. This is the most abstract level, where every self-consistent mathematical structure exists as a real universe. This challenges traditional notions of reality and even the existence of physical laws. These ideas are not just baseless speculations. Physicists are looking for plausible traces of other universes in our own. For instance, they study small anomalies in the cosmic microwave background, CMB, the remnant of the Big Bang, which could be evidence of collisions between universes. Additionally, theories of gravity in multidimensional space are also being tested in high-energy physics experiments. The detection of gravitons leaking into extra dimensions or unexplained gravitational fluctuations could be important clues for brane theory. However, confirming the existence of the multiverse is an immense challenge. Most multiverse models are beyond our direct observational capabilities, at least with current technology. This raises questions about the testability and scientific validity of these theories. There are arguments that the concept of the multiverse is merely a way to avoid difficult questions about the fine-tuning of the universe for life. The anthropic principle states that our universe has the precise physical constants to allow life to exist because we are here to observe it. If there are countless universes, then some of them would certainly have conditions suitable for life, and we are in such a universe. The scope of these speculations is truly astonishing. From cosmic bubbles beyond our sight to constantly branching quantum realities or multidimensional space-time branes, each theory opens a new door, challenging what we once thought possible and forcing us to confront profound philosophical questions about the nature of reality, life, and humanity's place in a larger cosmic picture. Whether proven or not, the idea of the multiverse and brane theory has enriched our understanding of the universe. It has pushed scientists to think beyond conventional limits, seeking creative solutions to unresolved cosmic mysteries. It also reminds us of human humility in the face of the unimaginable grandeur and complexity of the universe. The most important thing is the spirit of exploration and questioning. It is these bold questions that have led humanity from believing the Earth was the center of the universe to unraveling the mysteries of planets, galaxies, and now, other universes. We may never directly visit another universe, but through theoretical physics and observation, we can still envision and understand it. These theories also have profound implications for philosophy and even spirituality.
If there are countless universes, each with a variation of ourselves, then the meaning of individual existence is framed differently. It could change how we perceive free will, destiny, and the nature of consciousness. Whether the multiverse is merely a bold conjecture or a reality waiting to be discovered, it remains one of the most exciting frontiers of modern science. It invites us to dream, reflect, and continue to push the boundaries of understanding. The search for other universes is not just a scientific journey, but also a deeply self-exploratory one. So is our universe unique? Or is it just one of countless glittering jewels in an endless ocean of realities? The answer is still ahead, awaiting humanity's next discoveries. But one thing is certain. Asking this question has forever changed how we perceive ourselves and the space around us.
We are in a promising era where scientific tools are increasingly powerful and theories are increasingly sophisticated. Perhaps in the not-too-distant future, a breakthrough discovery will provide a clearer answer to this age-old question. Can we find direct or indirect evidence of the existence of parallel universes? Time will tell, but the search will not stop. By exploring these complex concepts, we not only expand knowledge, but also cultivate critical thinking and imagination. Modern physics is not just about numbers and formulas, but about daring to ask the greatest questions and daring to seek answers that could completely change our worldview. The multiverse is a powerful testament to that. From infinite bubble universes to floating space-time brains, the idea of other universes continues to challenge and fascinate us. And whether we are in one or countless universes, one thing remains constant: the presence of light, the fundamental building block of everything. In the next video, we will delve deeper into the quantum nature of light, a seemingly familiar phenomenon that hides incredible secrets fundamental to all understanding of the universe. Don't miss it.